Let's see how the SR latch works and how we are able to store logic 0 or logic 1 using an SR latch. Now the first step is at power up. So what happens when you power the circuit? When you power the circuit, I'm just going to say S is 0, R is 0, and either one of Q or Q prime is going to be a 0 and the other one is going to be a 1. Right? So we can look at that. So let's assume Q is 0 and let's see what happens. I can say that either Q can be 0 or a 1 because when you power up, there is going to be some electronic noise and the circuit is going to settle into some stable state. So for simplicity, let's say Q is 0. Now we have R is 0, S is 0, and Q is 0. So this 0 is going to propagate here and you get 0 nor 0, which is going to be a 1. This 1 is going to get propagated here and you have 1 nor 0, which is 0. You can look at the truth table for the NOR gate. And this 0 comes all the way here again and this circuit is going to be stable. So I can confidently say that one of them will be at 0 and the other one will be at 1. So this is a stable state. Essentially, you're able to store logic 0 right here. Let's go to the second step. So in our second step, I'm going to say I make S as 1. S and R are my inputs, so I can control S and R. I put S equals to 1 and R equals to 0. I say that Q equals to 0 and Q prime equals to 1. Now what would happen in this case? So let's plug in the values. So S is 1, R is 0, Q is 0, and Q prime is a 1. So this 0 propagates all the way here. You get 1 nor 0, which is going to be a 0. So this goes to 0. This 0 propagates all the way here. 0 nor 0 will be a 1. Right? This 1 is going to get propagated here. And you have 1 nor 1, which is a 0. It remains at 0. This 0 goes back here and you get Q as 1. So this circuit is going to settle at Q equals to 1 and Q prime equals to 0. So you have Q equals to 1 or Q plus equals to 1 and Q prime plus equals to 0. So this is the current state and this is the next state. It's going to take some time for the circuit to settle to Q equals to 1, which is why I have a plus sign here. And that's indicative of the next state. So if my current state is Q equals to 0 and I set my input as 1 and R to 0, my Q plus is going to be a 1. Let's keep moving. Now what if I change S to 0, R to 0, and Q plus was 1 in the previous step. Now that is going to be Q, which is 1, and Q prime will be 0. So what are Q plus and Q prime plus? So let's figure that out. So we were given that S equals to 0, R equals to 0, Q is a 1, and Q prime is 0. Now 0 goes all the way here. This becomes 0. 0 nor 0 is a 1. This one goes here. 1 nor 0 is a 0. And this 0 goes back up and you still get Q equals to 1 and Q prime equals to 0. Essentially, the values of Q plus and Q prime plus are not going to change. So you have Q plus equals to 1 and Q prime plus equals to 0. So they are holding the value. Let's go for the next scenario. In the next scenario, I set S equals to 0. I make R equals to 1. And the current value of Q is a 1, indicative of this. And the current value of Q prime equals to a 0, indicative of this. So what would be Q plus and Q prime plus? Let's figure that out. In this step, I was told that R is 1, S is 0, Q is a 1, and Q prime is a 0. So let's see what happens here. So you have this 0 propagating here. 1 nor 0 is going to be a 0. So this changes to 0. This 0 propagates all the way down here. 0 nor 0 will be a 1. This 1 goes up here. 1 nor 1 is a 0 again, so it stays there. This 0 comes down. 0 nor 0 is a 1, going to be stable again. So you have q plus equals to 0 and q prime plus equals to 1, and this is going to be stable. In fact, all of these are going to be stable as well. Let's look at the next step. Let's say we have s equals to 0. I change r equals to 0. So q equals to 0 and q prime equals to 1. So what are q plus and q prime plus? Let's figure it out. We have r equals to 0, s equals to 0, q equals to 0, and q prime is 1. So this one goes all the way up here. So 1 is a 0 nor 1 is a 0. That's fine. This 0 comes all the way down. 0 nor 0 is a 1. That's fine. This one goes back here. Again, it's going to be stable. So you have q plus equals to 0 and q prime plus equals to 1. So again, you're holding the value from the previous state. In the previous state, q was 0, and in the next state, q plus is 0. So you're holding it. Now using this logic, I can construct a truth table. So I have S, R, and the current value in memory, or that is q, and I have q plus. You have 8 combinations. Let's look at the first 6 combinations. So if s equals to 0, r equals to 0, and q equals to 0, do we have that combination? Yes, which is this one here. Your q plus is going to be a 0. When s equals to 0, r equals to 0, and q equals to 1, which is this combination, your q plus is going to be a 1. This is known as the hold state because when s equals to 0 and r equals to 0, the next value in memory is going to be the previous value. So it's the same thing. So you're essentially holding the value when s equals to r equals to 0. Now when s equals to 0, r equals to 1, and q equals to 0, which is basically one of these combinations here. In fact, here we have q equals to 1, but you can make it as q equals to 0 as well and try what happens. In that case, your output is going to be 0. And when your s is 0, r is 1, and q is 1, which is exactly this combination, your q plus is a 0. This is known as the reset state. You're resetting the value in memory. So you have s equals to 0, r equals to 1. That's the reset. Now let's look at s equals to 1, r equals to 0, and q equals to 0. So when s equals to 1, r equals to 0, q equals to 0, your q plus is a 1. So I can write q plus will be a 1. And the same behavior you're going to observe when s equals to 1, r equals to 0, and q equals to 1. It's going to be a 1. This is known as the set state. So s equals to 1, r equals to 0 is the set state. Basically, just by controlling the values of s and r, you're able to store a logic 0, which is the reset state, or you're able to store logic 1, which is a set state. This is how an SR latch functions.